All right, so let's take, what I decided to do was put all the problems, I just did screenshots, put all the problems on here. Obviously, not every single problem is going to be on the quiz. Tomorrow is the quiz, 6-1 to 6-3. All right, so I'm going to go through here. Like I said earlier, I have not made the quiz up yet. That's my job tonight. I'll do that tonight. Have it ready for you tomorrow. But let's just go through here and see what I could possibly put on the quiz. I definitely will not give you matching. I've never done that in my life, and I won't start today. All right. I don't know if I'll do this. There's a possibility. Okay. So there's a possibility that I could put one of these, give you a graph, and ask you. I just have to figure out. I could probably just take a screenshot from this. I can't graph it very nicely. That's the thing that I'm worried about. But I might give you one of these. It could be this. I do have an extra resource thing where it gives you quizzes and tests and stuff like that and practice problems. So I could take it from that as well. All right. But it'll be like, I probably will give you one like this. Okay. Where I give you a graph and you just got to tell me a couple things. That should be easy, right? All right. Look, that's a minimum right there. That's the vertex, right? Because it says state the vertex, state whether it's a max or min. Okay. Axis symmetry, domain and range. Right, I could ask you all that. That would probably be just like one question, though. All right, you got to get them all right. The axis of symmetry is the x equals. It's the vertical line that goes through there. So you just find out. Look, that's where it hits. Shh. That's where it hits right there. So the axis of symmetry, there it is right there. See, x equals -3. So if you know the vertex, axis of symmetry is easy. The domain's easy, right? And the range is maybe a little bit more difficult, but not that bad. It's just, where do my points lie on the y-axis? Well, they lie anywhere from where? From +2, do you see this? That's 2 on the y-axis, and up and above. All right, and that's what it's doing. Anything greater than or equal to, right? So domain and range. Yeah, that'd be a good one to do. All right, so expect one of those. All right. Let's see. I probably will not give you something where you have, I don't know. Yeah, I'll give you one of these. Okay. So, not the whole table, just one row. Okay. Would you stop making requests, or I'm going to make it as hard as I possibly can? Okay. So, I do my way. This is not up for grabs. This is not, hey, what would you like to see in your quiz? No, I'm telling you what's on the quiz. All right. So, don't ask me anymore if this could be on it and that can be on it. Yeah, if you have a question on how to do these, then that's fine. But don't ask me what's going to be on it, because I'm telling you right now. These were initially blank, right? Because this is the answer key. So I'll probably ask you each of those. All right. It's not much different than the last one, except they don't give you the graph itself. They just give you the function. All right. And you tell. So yeah, we'll do one of those for sure. Just one. That's kind of the same thing, isn't it? 27 to 34. So yeah, I'm not going to give it to you as a chart like this. All right. But any of these, it's all the same kind of question. I could ask you any of those. And then, sure, let's do one of these where you have to pick some ordered pairs and then graph it. All right. So let's do one of those for sure. How many is that? 3? Is that 3? Yeah. All right, that should be good, because that's the first section. Yep. And none of that stuff. Don't worry about that. All right. This is section 6.2. So that was 6.1. All right. Here's 6.2. I don't know. We kind of did this, didn't we? Except for the minus and the plus in that parentheses. That's really the only difference between that and the other stuff. So this is a maybe. Maybe. I'll give you one of those. Here's a definite. Okay, I will definitely give you in this form right here, and you have to put it in this vertex form. That's what the H and the K. All right. So do a little completing the square, right, in order to put it into this form right there. All right, so take that and turn it into that. And first, I'll give you maybe one or two of those. Okay, maybe two of them. I don't know. It depends on how many other problems I need to give. I want to kind of balance it out, not give you a whole bunch of problems that are exactly the same. Okay, I want to give you a choice. So I might give you a couple of those. And then I'll ask you to graph it as well. So probably maybe one where you don't have to graph it, maybe one, maybe two, I don't know, where you have to graph it. So this is kind of the same thing, except you need to graph it. Yes. We will. As soon as we go through what's going to be on here, then we'll hit which ones you want to ask about. All right, I believe this is 6-3. Is that right? Yeah, because that's 1 through whatever, and this is 1 through, so this is probably 6-3. How many do we got so far? Like 5 or 6, something like that? All right. So let's see. This is a maybe. Okay, these things right here where I give you the graph. It's kind of like what we did earlier, a little bit different because I don't think they asked you the y-intercept before, all right? But find the y-intercept, find the zeros. We didn't ask that before. Yeah, so this will probably, I'm changing this from a maybe to a, yeah, that'll be on there, okay? So definitely one of these. So I give you the graph, and these are your answers, okay? That's your y-intercept, and those are your x's, or your zeros. Everybody with me on that? Okay. All right, what's this next thing say? Find the zeros. Absolutely, we'll do one or two of those, all right? All it is just taking this, putting it into that vertex form, right, that x minus h squared plus k thing, and then just finding me the zeros right there, okay? See that? Completing the square is a big part of this, and a couple of the other ones that we did earlier. We'll go over that. Okay, we're almost done this. And then I don't think I am going to have you use Desmos on this quiz. Maybe as we go on a little bit later with this chapter, do some things that may... Actually, I don't know if we do any more graphing, though, to tell you the truth. Let's not, okay? Graphing calculator, let's not. Let's stick to just putting it into that vertex function. So out of the ones that I talked about, I'll find 10 of them, put them on the quiz, and you should be good to go. Is that helpful? All right, now let's do what Hunter wanted to do. Let's do some of these. Like which ones? Like you want to start down here? You want to go up here? They're kind of, let's come up here. Let's just put it into that, and then we can look to see. I mean, because really, this is the same thing as this. Or let's just do one of these. Let's do number 5. It's an easy one. Well, easier, I guess, than the others. Anybody, somebody write that down so I remember. X squared minus 5x minus 14, right? Can you remember that? My mind, my old age. X squared minus 5x minus 14. Okay. And what are we trying to do to this? Find the y and x intercepts. So the x intercepts is finding the zeros, all right? So just make sure that you understand what they're asking for. The other problem, it said find the zeros. That's the same thing as finding the x intercept. Well, kind of. Except for the x-intercepts, they write it as an ordered pair. Okay, when it says just find the zeros, you would just say -3 and -2. Does that make sense? All right. So, did we do the right one? Oh, that one right there. Yep. This says find the zero. See how the answer is? It's just -2 and 7. It's not -2, 0, 7, 0. So that's the difference. That's the only difference there. All right, so it's f of x. That's what I was looking for. All right, so find the zeros, right? So if I find the zeros, what do I do to this? I set it, what? Equal to 0. That's right. So x squared minus 5x minus 14 equals 0. So now I just have to solve for x. There's a couple ways you could do it. You don't have to complete the square on this because it just says find the zeros, right? It doesn't say to put it into the vertex form. So let's see. Oh, this factors, doesn't it? Yes, this actually works pretty good. Probably what I'll do is I'll probably go through there, find one that's an easier one like this one, where it just factors really simple, and then find one where it doesn't factor. So how would you solve for x if this didn't factor? Yeah, the quadratic formula, okay? So I want to make sure that you know how to do that. All right, so this does factor, though. Do you remember how to factor just a regular trinomial? These two have to multiply to be negative 14 and to add up to be negative 5. You getting good at this now? So what are we going to use? That's it, negative 7 and positive 2. Good. So you should be able to look at that, right? Just do a little calculation in your head, right? A little multiplication, see what multiplies to be negative 14. I mean, there's not that many things, right? There's 14 and 1 and there's 2 and 7. That's it, all right? You might have to change the signs a little bit, see which one works, but negative 7 plus 2 is negative 5, and negative 7 times 2 is negative 14. You're good to go. How do I find my zeros then? I take that x minus 7. What do I do to that? Set it equal to 0. And at this point, you could probably have done this right in your head. You probably could have gone from here to here. It's fine with me. Okay, I'm just showing you the steps because that's what teachers do. Okay, add a 7. I'm not even going to show that step. That's not needed. X is what? 7, and x is negative 2. And there you go. It said find the zeros, didn't it? And those are your zeros. If you wanted to write it negative 2 comma 7, if you write x equals like that, that's fine too. If you just wanted to write negative 2 and 7, circle it. I'm okay with that as well. Make sense? Yeah, that was the easy one. So let's find another one. Let's find a crazy answer like this one right here. Yeah, let's do that. Now let's do one with just a fraction, like number 7. Is that all right? That's a good one. It's got a negative out in front, plus it's still in that form right there. So let's do that. Can you remember it? Negative 3x squared plus 5x plus 2. What is it? Negative 3x squared plus 5x plus 2. All right. I'm telling you, my short-term memory is like non-existent. So equals, this is f of x equals, then it says find the zeros. So what are you going to eventually do to it? You're going to set it equal to 0. Now, is this something you want to try to factor? No. Okay, I would not try that. So what would you do? What's the best recourse here? Use the Pythagorean theorem. All right, so let's do it. Oh my gosh. It's quadratic formula. It's not Pythagorean theorem. It's not the first time I've ever done it. I do that a lot, actually. In fact, in my geometry class, we were doing Pythagorean theorem, and I said use the quadratic formula. I'm like, what are you saying? We don't even know what that means. I'm like, I meant Pythagorean theorem. So you get the idea. Quadratic formula. What is it? Negative b, negative 5, plus or minus b squared, which is 25, minus 4 times a, which is negative 3, times c, which is positive 2, all over 2 times a, which is, we can do that in our head. What's that? Negative 6. All right, and then we just simplify this, really. This is just I almost did it again. This is just a what? Quadratic formula problem. It's really all it is. So plus or minus, but it's good for us to do this again. Square root. What's that? Plus 12 to 24, yeah? Over negative 6. Oh, that's nice, doesn't it? Come out nice. This is what? 49. Square root of 49 is 7 over negative 6. So what do you do here? Do you leave it like this? I think somebody on the last quiz or test or something left it like this. Anybody want to own up? Somebody did. I don't know. I can't remember who it was. So what are we going to do? I'll show the steps. Everything is being divided by this negative 6. This is being divided by it, and this is being divided by it. Okay? So make sure you understand that. So it's negative that, and then, is that the answer to this? Doesn't seem like that was the answer.
Don't you have to like negative 5 minus 7 and then divide by 6?
Oh, of course. I'm just perfectly fine and dandy. Let's try it again. That's why it didn't come out. Negative 5 plus 7 over negative 6. And what else? Negative 5 minus 7 over negative 6. I'm just doing this to keep you sharp and make sure that you're paying attention. Do you believe that? Do you believe that?
No.
Yeah, don't. All right, so what is this? 2 over negative 6, and that gives you negative 1/3, so there's 1. And this is negative 12 over negative 6, that gives you positive 2. And there you go, there's your zeros. That looks more familiar. There you go. That other one probably wasn't any more, well, you know, that one that came out kind of weird like that. I think what they probably, to find the zeros, I don't know, what would you do with that? Oh, I know, of course. You set this equal to 0. You set this equal to 0, add a 5, divide by 2, take the square root, add a 1, boom, you get this. Did that make any sense? What? Look, you set this equal to 0. So it's 2 times parentheses x minus 1 squared, right, minus 5. If that was equal to 0, what would your first step be to get x by itself? Add a 5. That's what I said. Okay, so you add a 5. Then what's your next step? No? This 2. Divide everything by 2. Okay? Here. This is a screenshot, so it looks a little bit pixely, but so add a 5. Now watch. Come on, listen. Add a 5. Then what? Divide by 2. Then square root, plus or minus, and then plus 1. You do all that, you simplify it, and then that's what you would get. Why does that keep going to white? I don't know why. There you go. Okay. I don't have to do that for you, do I? Let's do one of these. Let's do one of these where you have to change it into vertex form. Oh, we didn't do an inequality. Yeah, we'll put an inequality on there too, okay? Almost forgot about that. Everybody got that? All right, and so you got some inequalities here as well. Let's not do the one where you use the graphing calculator. Let's do one of these, x-intercepts. So let's do, I don't know, what's a good one to do? Let's just do the easier one first. Let's do that one. Okay? X squared plus 5x plus 6. Do you think I can remember that? Probably not. So x squared plus 5x plus 6. See? I remember. Thanks. All right. So what are we trying to do? We're trying to change it into that form, right? F of x equals. What are we trying to change it into? That vertex form. What's the vertex form? A times x minus h squared plus k. So I want to change this to make it look like that. How do I do it? Well, I need a perfect square, don't I? All right, so what I'm going to do, I'm going to go x squared plus 5x. What do I do to this 6? This time we don't set it equal to 0. All right, when I'm changing into this form, I'm not trying to solve for x. I'm just trying to put it into this form. So what do I do with this 6? I'll put a plus and a blank, and then I'll just push this over. See what I did? All right, so I just moved this over, left a spot. Now, I want to fill in this spot to make this into a perfect square. Remember how to do that? Yep, take the middle one, the middle coefficient, divide it by 2, and square it. What does that give you? 25 over 4. So what do I do here? I add 25 over 4. Now, you got to be careful in this next part because you're so used to it being 0, so whatever you do to one side, you do to the other side. But we're keeping everything on the same side here. We're not putting it on this side. Everybody see that? I want that f of x just to stay there. So if I added a 25 over 4, what am I going to do over here? Subtract a 25 over 4. So basically, I haven't done anything, have I? Okay, as far as changing the value of this. I have not changed the value of that function at all. All right, all I did was just add a 0. But I made it look a lot different, and that's all we're trying to do. We're just trying to make it look like this. Now, I made this into a perfect square, so it should look like this. So what goes inside here? right? X squared is this x squared. How do I find out this last one? I could take the square root of 25 over 4, or I could take half of the middle one. You're going to get the same exact thing. If I take the square root of 25 over 4, it's 5 over 2. If I take half of this, it's 5 over 2, right? Why? Because we took half of it and we squared it to get that number in the first place. So all I'm doing is just going backwards, okay? So this is plus what? 5 over 2. And then what do I do here? Well, find a common denominator, right? Which, oh, it's not 24. I'm getting ahead of myself. So it would be 4, wouldn't it? This is over 1. 1 times 4, 6 times 4, minus what? 25. So what's this going to be? Minus 1/4. Did I do that right? Let me check this one. I got the book in front of me. I should just look instead of going way up to the top again. Oh my goodness. You know what I did? This would be correct if I would have read the instructions to the problem. I was wondering why. Let's go all the way back up here. You guys got to keep me... Oh, stop it. You guys got to keep me on the ball here. So where was it? Right here. So this was not one of the ones where you turned it into the vertex form, was it? Doesn't say it. That's what I was doing. Well, what I just did was right. It worked. So what if we had a problem like that and I said, turn it into, what do they say? Write it in vertex form. Then you would do what I just did. So we didn't lose anything from that. It's just not the same answer as this because I didn't read the daggone instructions. And that's what you should always do. Again, of course, I did that on purpose just so that you could see. That's right. It's always your fault. So I feel better about myself then. Okay, we will do it now. But yes, we will. But that's what it said to do. All right, so we have to find the x and the y intercept. So we're basically solving for x, and the y-intercept, remember that? To find the y-intercept, you set the x's equal to 0. Okay, so let's do that one. So I was right on this for what I was trying to do, all right? But that's not what they ask you to do. So let's do what they ask you to do. So let's write it down again. F of x equals x squared plus 5x plus 6, okay? Let's do the easy part first, find the y-intercept. So if I want to find the y-intercept, what do? I set x equal to 0. So that's super easy. That's 0, what is it? It's 6. So the y-intercept is, it's an ordered pair. Don't just put 6, okay? It's 0, 6, because we set the x equal to 0. Make sense? All right, so that was easy. What about finding the x-intercepts? So you could solve for x, right? Basically just solve for x. So it's x squared plus 5x plus 6 equals 0. Yeah, this factor is easy. 3 and 2. Do you agree? Multiplies to be 6, adds up to be 5. So what's x? Negative 3. What's x? Negative 2. And there you go. Did the thing say to graph it? Can't remember. Let me look. I got the book here. Yeah, then graph the function. Okay, so let's graph it. It doesn't have to be like a perfect graph. You just want a couple key things in your graph. The y-intercept is 0, 6, so 1, 2, 3, 4, 5, 6. So, and then let's go this. 1, 2, 3. All right, so here's how easy it is to graph now once you got that information. Put 0, 6 so that you know it's going to do that. By the way, is this going to go up or down? Is it going to open up or open down? So open up because this thing is a positive right here, okay? And it goes through the x-axis at -3 and -2. Okay, and then watch this. If you went over 2 here, how far did you go up? You went up. You went up 6. So if I go over 2 from this one, I'm going to go up to here. You see that? Now you got to find your vertex. You could find your vertex. How do you find your vertex? Do you remember the little formula? Yeah, so your vertex, I'll write it down, is negative b over 2a. Is that right? And then negative b squared over 4a and then plus c. So you got to remember that for your vertex. And so we can, and where's the vertex? The vertex is going to be down here somewhere, isn't it? Well, let's find exactly where it is. So this is your A, B, and your C. So what is your A? It's 1. What's your B? 5. What's your C? 6. So it's negative B, so it's negative 5 over 2 times A, which is just 2. Now, see, this doesn't come out super pretty, but that's okay. What is negative 5 over 2? Negative what? 2.5. All right? What's this one going to be? Negative B squared, so that's going to be what? Negative 25 over 4 times A, which is just 4, plus C, which is 6. Let's make this 24 over 4. You see what I just did? Just turn 6 into 24 over 4, so that's negative 1/4. Okay? That looks familiar, doesn't it? Look at that. Look. Just watch. Look. See what I found that vertex, didn't I? What was it? Negative 5/2. You see that? And it was negative 1/4. Wasn't it? Look at that. Okay? See how they come together? So where's negative 2.5? Negative 2.5. And you would think it would be right there, wouldn't you? Because it would split the middle of those two. Yeah. And then how far do you go down? Just negative 1/4. And then, let's go back to red. And then you draw your graph. So it's really not that difficult. Oh, missed it. It's close. Good enough. Doesn't have to be perfect. Should hit right there. And there's your graph. It should be a little bit curvy, more curvy than that is, but it would look better. I took my time maybe. And that's how you would graph it. You don't even have to really do this. You could have just kind of guessed where that vertex was. I'm not going to be that particular. I'm just going to see what? If it goes through. Oh, I missed that completely though, didn't I? That should have gone through that point. Oh, let's try that again. All right, so it should have gone like this. Oh, that's even worse. Oh, I'm going to stop trying. Anyway, you get the idea. All right, it goes from here down to here, up to here. All right, just make sure that it goes through the y-axis. Make sure it hits your x-axis right here. And then how do you find that point? Well, depending on how far you went over and up here, the same distance, right? So you got these 2 points, you got these 2. It doesn't even matter what your vertex is. You know it's going to be somewhere in the middle. You know it's not going to be way down here like this, all right? So I don't even care if you put the vertex. But if you wanted to be really particular about it, you could figure out where the vertex is supposed to be, all right? Make sense? All right. All right, what else? Oh, I got to go all the way back up there again. Let's do it this way. What about inequality? You want to do one of those? Yeah, this one really... Yeah, that one's really not any different than if it was in equals, okay? This is not the one where you have to put the graph and try the points and all that kind of stuff, okay? So you just put the graph. To graph it, though, if it's greater than, where's your shading going to go? On the outside of it, okay? If it says less than, it's going to be on the inside of the parabola, all right? You could always pick a point to double check and make sure, right, if it's going to be inside or outside. But yeah, that's really the only difference with that. All right, what are some other things? I think that last section is probably the hardest, wasn't it? That 6-3 out of everything. Did we do this? Yeah, in vertex form. We did that problem where we put it in vertex form. So that could be any of those. Same thing here, put it in vertex form and graph it. And what if it was in vertex form, like this one right here? All right, let's do an easy one. What if it was in that form? What does this tell you just by looking at it? Once you put it into vertex form, what does that tell you? It tells you the vertex. What's the vertex? Just looking at this. -3, -4. That's your vertex, okay? You could always find the y-intercept by just making those y, so the y is 5, right? And that's really all you need, isn't it, to graph it? You know your vertex. You could find your x-intercepts if you wanted to. But yeah, you just need a few points just to kind of get the general shape of the graph. I'm not being super specific on your graphing, all right? I just need to know that it goes through some key points. That key point is either the vertex, it's the y-intercept, it's the x-intercepts. If you can get those points, you should be able to give me a nice little sketch of your graph, all right? So I'm not going to be crazy tough on that kind of thing, all right? Yeah, what about this thing right here? It says find the vertex. If it's already in this vertex form, finding the vertex is easy. It's just 6, 1. Remember, it's always the opposite. Remember, it's x minus h, so the h is 6 and the k is 1. So that would be that. How do I know it's a minimum? Because I know this thing opens what?
Down.
This one?
Up.
Right, because there's a positive in front of there, right? So it opens up. That means my vertex is going to be a minimum, right? Because it opens up. If you had a negative, like right here, what does that mean? That means it's going to open down, and so your vertex is a maximum because it's at the highest point. So a lot of these things, just by putting in vertex form, tells you a lot about it. What does that -3 tell you compared to just a regular x squared graph? Well, it opens down, that's true. We talked about that already, but the 3 tells you it's what? It's steeper, okay? Why is this one flatter? Because it's less than 1, okay? If it's greater than 1, it's steeper. If it's less than 1, I should say the absolute value, okay? The negative tells you if it opens up or down. The number itself tells you if it's steeper or flatter, all right? There's your vertex. You know if it's maximum or minimum. So that should be pretty easy if I gave you one of those. Agreed? Yeah. What did I say over here? This one is where you just plot some points, right? Just make a little table, x and y, just throw in a bunch of points to get the basic shape of your graph and then graph it, all right? I'll probably only put one of those on there, all right? This stuff right here, we just talked about it, right? What does all this stuff do? Right? Yeah, on this one, we didn't talk about like moving it left or right, did we? We hadn't got to that yet. All right, so that's why the vertex is basically the same as the y-intercept, all right? So that's why that's true right there, okay? You know if it opens up or down. We just talked earlier about the domain and range, steeper and flatter. Yeah, that's not that big of a deal. Yeah, so that early stuff is not near as hard as what it is towards the end. Because we used a lot of that early stuff to get to where we were at the end of it. So that should be good. All right, even though I kind of messed up a couple times today, you could always, it doesn't matter. I still listen, okay? I mean, we all laughed and stuff like that, but I mean, I make mistakes too. I'm not ashamed to admit that I make a mistake. And I made a couple mistakes, but we rebounded from it, right? We found out what I did, and then we fixed it. And that's life. That's what you guys do. Just because I'm a teacher doesn't mean I'm perfect, all right? So go back and watch the lessons. Okay, you don't have to watch the whole entire thing. Just go back to where I do some examples. Right, just scroll through it on YouTube, find where I do the examples, and just watch how it compares to this stuff right here, and then you should be good. Is that all right? All right. I mean, my goodness, other teachers. Mia, at Caravel, did other teachers give you such a detailed review for a quiz? Probably didn't even review for quizzes, did they? They probably just said, we're going to have a quiz. And I used to be like that. I used to be, hey, tomorrow we're going to have a quiz, or Wednesday we're going to have a quiz. It's over these sections. Make sure you study it and be ready. That was my review. But
a paper like that, which is like all good.
okay,
It was online.
right. All right, so there you go. That's it. Be ready for it. Quiz tomorrow, 6-1 to 6-3.